heard the term absolute zero to describe temperature? Well, this is where it comes from. At negative 460 degrees Fahrenheit, or absolute zero, molecules are not moving at all. They have absolutely zero kinetic energy. The closest we have ever come to observing this temperature is in outer space in a place called the Boomerang Nebula. It's negative 458 degrees Fahrenheit. On Earth, the coldest temperature is in Antarctica. That's negative 128 degrees Fahrenheit. The hottest place on Earth is Death Valley in California at 134 degrees Fahrenheit. And back out in space, the surface temperature of the Sun is 9,941 degrees Fahrenheit. As humans, we prefer to live in temperatures somewhere between Antarctica and Death Valley. So we have learned how heat moves from place to place to our advantage. Thermal energy transfer happens in three ways: convection, conduction, and radiation. This is a picture of a blacksmith's forge, and if you can imagine standing next to the fire, you know that you could feel the heat even if you don't touch the hot coals themselves. This is radiation, the transfer of thermal kinetic energy between two objects without those objects touching. You can also see the fire burning really hot and orange in the middle, so hot that the piece of iron in the middle of the fire is glowing and soft enough to bend. When two materials of different temperatures touch, like the iron and the coals of the fire, heat is transferred by conduction. Finally, the air over the fire is heating up and will float up and carry the smoke into the sky. This is an example of convection, which refers to the movement of thermal kinetic energy in a fluid, like air or water.
So we've discussed the three ways to transfer thermokinetic energy. The first being radiation, the second being conduction, and the third being convection. So what we're going to do now is use our volunteer Aria to show you guys radiation. So if I could get you to hold both your hands up to the infrared camera. Very good. So we can all see that her hands are about 98.6 degrees, or her own body temperature. So what we're going to have you do now, Aria, is bring one of your hands right here above this lizard lamp. And all this is right here is a ceramic heating bulb that gets warm, and we're going to have her put her hand right there for 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you, Aria. Now if you would show both your hands to the infrared camera again. We can all see that that right hand that she had underneath that ceramic heat bulb now has more thermokinetic energy in it than her left hand. She was not in direct contact with that bulb. Her hand was about a few inches away. So we know by having learned about radiation that the thermokinetic energy radiated from the ceramic heat bulb into Aria's right hand, which is why it looks like it is now warmer than her left hand. So we just saw the radiation demonstration. The next one we're going to see is conduction. We're going to use our same volunteer, Aria, and we're going to be using this black board. This black board is room temperature. As we can see through the infrared image, it is around 74 degrees Fahrenheit. What we will do now is have Aria put your right hand right there on that blue water and light logo and press pretty hard for about 10 seconds. We'll count down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you very much. Now if we focus the infrared camera back on this board, we can now see her handprint. With what we know about conduction, her hand was in direct contact with this board, creating a heat transfer. So the thermokinetic energy transferred from her right hand into the blue water and light logo and is now showing up on the infrared camera. Thank you very much, Aria. Our final demonstration is going to involve convection. So for this example, we're going to be using the ceramic heat bulb again, and Tim is going to take the smoke gun and put the smoke inside of the clear tube when he puts it over the ceramic heat bulb. The reason we're doing this is we're creating a temperature difference to get the convection to naturally carry the smoke through the clear tube. This is the same thing that happens in your fireplace chimney at home and the same thing that happens in the smokestack on the power plant.